Think about the last thing you did online. Maybe you sent an email or just watched a cat video. Whatever it was, you sent these little packets of data flying across the internet. But for that journey to even be possible, your device has to use not one, but two totally different addresses. And how they work together is frankly brilliant.
So why the two addresses? I mean, why the complexity? Why can't we just have one and call it a day? Well, let's dig into this two-layer system, because it's pretty fundamental to how the internet works.
The easiest way to wrap your head around this is with an analogy. Think of an IP address like your home's mailing address. It gets the mail to the right street, the right building. But the MAC address, that's like the name on the envelope. It makes sure the letter gets to the specific person inside that building. You really need both to make sure the delivery is successful.
Okay, so let's properly introduce our two main players here, the IP address and the MAC address. They are absolutely a team, but they play on completely different fields.
See, the IP address is the long-distance traveler. It's the big picture address that guides data across the entire global internet. But the MAC address? It's a total homebody. Its only job, its entire purpose, is to find the very next device in the local chain. They operate on totally different scales.
Probably the best way to really get this is to follow one of these data packets on its little adventure. So let's pretend our packet needs to get from your computer all the way to a web server, maybe on the other side of the planet.
Now, the very first challenge for our packet isn't some huge leap across the globe. Nope. It's just getting out of its own neighborhood, your local network. And to do that, it needs to find the front door. In the networking world, we call that door the default gateway. For pretty much all of us at home, that's just our Wi-Fi router. It's the one and only exit point connecting all your local gadgets to the huge open internet. Every single piece of data you send out has to go through it first. So your computer knows the IP address of your router, its mailing address. But remember our analogy? To actually hand the packet over to the router, which is sitting right there in the same room, it needs its specific name. It needs its physical MAC address. So how on earth does it find that?
Well, it uses this really clever little protocol that basically acts like a neighborhood directory, letting all the local devices introduce themselves to each other. This is the Address Resolution Protocol, or ARP for short, and its job is beautifully simple. It's a conversation starter. A device uses ARP to basically shout out, "Hey, I have this IP address. Can the owner please tell me their MAC address?" And here's the key. This conversation can only happen inside the local network.
Here's how that little chat plays out. Your computer broadcasts an ARP request to everyone on your Wi-Fi. Your phone, your smart TV, they all hear it, but they just ignore it. But your router, the gateway, recognizes its own IP address, and it perks up. It sends a reply directly back saying, "Oh, hey, that's me. Here's my MAC address." And just like that, problem solved. Your computer knows exactly where to send the packet to get it out the door. Okay, so once our packet gets through that gateway, it's out on the wild internet. It's starting a journey that could be dozens of hops between different routers around the world. And this is where the real dance between the constant IP address and the ever-changing MAC address really gets going. And this brings us to what is maybe the single most important rule of internet routing. The source IP address, your computer, and the final destination IP, that web server, are locked in. They are set in stone. Like the to and from addresses on an envelope, they never ever change for the entire trip. But, and this is the big reveal, the MAC addresses, they change constantly. At every single stop, every hop from one router to the next, our packet gets stripped down and put into a new local delivery frame with brand new MAC addresses. This table shows you exactly what's happening. Look at the IP address columns, rock solid, they don't change at all. But now look at the MAC address columns. It's a constant switcheroo. The packet starts by going from your PC's MAC to your router's MAC. Then your router rips that off and sends it from its MAC to the next router's MAC. This happens over and over and over again, a brand new local delivery at every single hop. And then, finally, it arrives. So you see the beautiful teamwork here, right? The IP address was the North Star, guiding the entire end-to-end journey. The MAC addresses were the local couriers, handling the delivery for each individual step along the path. It's a really clever two-layer system. But there's a catch.
This whole elegant system is built on one very fragile foundation: trust. Specifically, it trusts that devices on the local network are telling the truth.
I mean, think back to that REP conversation. Your computer just blindly accepts the reply it gets. It has no way of verifying that the device saying, "I'm the gateway," is actually the gateway. So what happens if a device on your network just lies?
Well, you get a classic attack called ARP spoofing. An attacker on the same Wi-Fi network, say at a coffee shop, can just start sending out fake ARP replies. They can tell your computer, "Hey, I'm the router now. Send all your internet traffic to my MAC address." And your computer, not knowing any better, does it. It starts sending everything straight to the attacker. Another nasty trick is called MAC flooding. This one targets the network switch itself. An attacker just bombards the switch with thousands upon thousands of fake MAC addresses until its little memory table completely overflows. And when that happens, the switch panics, its brain breaks, and it just starts broadcasting every single packet to every single device. It's a total privacy nightmare.
Now, because of these very real threats, network administrators can't just rely on trust. They use powerful tools like port security, which basically acts like a bouncer. It lets them lock a specific port on a switch to a single authorized MAC address, stopping these kinds of attacks before they can even get started. So let's just boil this all down. What are the key takeaways? First, IP addresses are for the big picture, the final global destination. Second, MAC addresses are for right here, right now, the immediate next hop. Third, that little ARP protocol is the local directory that connects the two. And finally, this whole system is incredibly efficient, but its foundation of trust is also its greatest weakness. And that leaves us with a really big question, doesn't it? Our entire digital world, everything we do online, is built on this system that was designed decades ago for a much smaller and, frankly, a much more trusting internet. As we connect billions more devices, from our cars to our fridges, you have to wonder, is this system still good enough for the world we're building today?